Good morning. Today, we are going to review transformations and complex numbers to prepare for the test. I am going to work through this review. I can't do all the problems, but I will try to do as many as I can. I am not covering anything new today. So what that means is if I don't get through everything, it's okay. It's all review. Okay, so let's go ahead and get started. There we go. Technical problems left. There we go. There we go. Okay, so first let's spend a little bit of time talking about transformations. And most transformations we talk about is from Vertex Form. And so I wrote the form for Vertex, and I just want to remind you that that number out front, if it's positive, well, I should say if it's bigger than 0, then it causes it to stretch. So it takes that parabola and stretches it. Some people say skinnier. So like if I were to change this to a 2, a 3, a 4, the larger I make it, the skinnier it gets. And then if I were to put a fraction here, so any number between 0 and 1 that's a fraction, it actually makes it go wider. We say compressed. I think the district assessment uses the word wider. And then we have our H that shifts it to the left and right. And we have our K that shifts it up and down. So, which correctly identifies the values of the parameters A, H, and K for this function. So when I look at this, A is number out front. So I would say A is -1. Okay, so when I'm taking a multiple choice test, I like to cross off the one I know it can't be. I crossed that off because I said A is +1. Now H, this is where it might get confusing because the formula has a minus. So technically H is the number right here without the minus. So I would say H is 1. And then I would say K, and again, K is just the whole number. I would say K is -4. So I would say, let's see, A is -1, H is 1, K is -4. That looks like it's B. What's interesting about this is HK is the vertex. So 1, -4 is the vertex. Okay, so you should be able to look at, especially in vertex form, and tell me what happens. You know, what happens as I increase this value? What happens as I change this value? What happens as I change this value? Okay, so again, we're not going to do all of these practice. I have to save some for you so you can practice. So which function includes a translation? Translation means move. So we want it to go 4 units to the left. Okay, so in a vertical compression to the graph of x squared. So it's kind of interesting. I always think of it as the opposite. So when there's a -4, that shifts it to the left 4. I'm sorry, to the right 4. So -4 will shift it to the right 4. -4 would shift it to the right 4. +4 shifts it to the left 4. +4 shifts it to the left 4. So the plus shifts it to the left. The negative shifts it to the right. So we want 4 units to the left, so I'm going to use one of the plus ones. So it's either going to be this one or this one. And then a vertical compression. So to be a compression, to make it wider, it needs to be a fraction between 0 and 1. So I would say 1/3. 1/3 is between 0 and 1. So this will cause it to have a vertical compression and also shift it 4 units to the left. On your test, you have access to Desmos. So if you're confused or you're like, I don't know, don't be afraid to use Desmos. So let me show you that real fast. So they were talking about the parent's function x squared. And they were saying which function moves it to the left. So I'll type in all of them. I'll say, okay, 1/3 x minus 4 squared. Did that move it to the left? No, it moved it to the right. So not that one. Bye-bye. B was 3x minus 4 squared. Did that move it to the left? No. So it's not that one. I'll turn that one off. The third one, did that move it 4 to the left? Yes. Okay. And also, so did the next one. That also moves it to the left. Now, and then which one is more compressed? Compressed means make it fatter, wider. So which one's wider would be this one right here. So I would choose the purple one. So don't be afraid to use Desmos to your advantage on the test. So the answer is the purple one. Okay, so not that one. So this one moved 4 to the left and it got wider or compressed. Same thing. All right, so I'm going to skip over to complex numbers. Well, first, we have something quadratic. This is called standard form right here. And so all we know from standard form is A is negative, so it opens down. So it looks like this. Because the A is negative. And so the first question, is the vertex a minimum or maximum? Well, because it's a negative, it's going to be a maximum. Now, how many solutions does this quadratic have? There's a formula you can use. It's called the discriminant, and that is b squared minus 4ac. And long story short, if you get bigger than 0, that's 2 real, equals 0, 1 real, less than 0, 2 imaginary. Now, it might be easier in this case. Again, if you have access to Desmos, feel free to use the formula, or you can just go type it in, see what it looks like. So close these out from before. And I'm going to type in y equals negative x squared minus 16x minus 64. So the question was, does it have a minimum or a maximum? Well, there you go. It's a maximum. And then how many solutions does it have? Looks like it just touches there once. So I would say one solution. That means the discriminant is 0. If I did b squared minus 4ac, I would get 0. Okay, so I would say 1 real. For those of you that are more algebra prone, which is fine, so b is negative 16, so I'd say negative 16 squared minus 4. I'm just using this formula. A is negative 1. C is negative 64. If I type that in my calculator, I get 0. So because it's 0, I would say 1 real. Okay, so this is called the discriminant. This tells you how many solutions there are, or you could just look at the picture. Next, we did complex operations. So you should know how to add and subtract complex numbers. So this is an example of a subtraction. Don't forget to distribute the negative in. Here would be multiplication. Can you distribute the 4i to both of those? I don't have time to cover all of the operations, but I will at least cover 8. I think 8 is the hardest. So as a reminder, and it's actually kind of interesting. I'm not sure if I showed you this yet or not, but on the calculator, you could actually type this in. So you could type all of these in. If you have one of these, which I guess you may not have one. But you can see all I did was type it in. 2 plus 3i times 2 minus 5i. And I already know the answer is 19 minus 4i. So this calculator is very handy. The I button is right here at the period. It's yellow, so you hit the yellow second button, then the decimal, and that's how I got the I. So just in case you don't have a calculator, we'll use the distributive property. So I'll go 2 times 2 is 4. And then I'll do 2 times negative 5i, which is negative 10i, followed by 3i distributed. 3i times 2 is 6i. And then 3i times negative 5i, that'd be negative 15i squared. Now, I squared, by definition, I squared is negative 1. So when I'm doing these problems, I could say, okay, that's 4 minus 10i plus 6i. And then if this is negative 1, and I'll show every step. So all I did was change I squared to negative 1. So this is going to be a plus 15. Because negative times negative is positive. So I have plus 15 plus your 4 would be 19. And then we have negative 10i plus 6i would be negative 4i. And in case you forgot, that's exactly what I had on the old calculator. All right, let's keep going. Sorry, I'm trying to decide what to cover. I only have a few minutes. Number 12, you also need to know how to do that. Again, if you have a TI-83 and you type the numerator in parentheses, so what I'm trying to say is if you type this in as negative 2 plus 2i divided by so the question was, if you use a calculator, do we still have to show work? Yes, for my practice, I want to make sure that you understand how to do these by hand. But on the district assessment, I don't need to see your work. I don't ever get your work. I just need you guys to know how to score what okay for the district assessment, okay? So, but if I type that in, we can see, and then I can change that to a fraction, math, enter, enter. And so I already know the answer is negative 14/25 plus 2/25 I. And I would say these are probably the most difficult imaginary ones to work through. What do? You try to get rid of the I. You multiply by what's called a complex conjugate. So if this is 4 minus 3i, you multiply by 4 plus 3i. Numerator and denominator. And then from there, you distribute. So I would take negative 2 times 4. That's negative 8. I would take negative 2 times 3i, negative 6i. So I distributed the negative 2. And now I'll distribute the positive 2i. 2i times 4 is 8i. And then 2i times 3i is 6i squared. So that's the numerator. Denominator, I still need to distribute 4 times 4, 16. 4 times 3i would be 12i. Negative 3i times 4, negative 12i. Notice these cancel. And why do they cancel? It's because you multiplied by the complex conjugate. These should always cancel. If they don't cancel, you messed up. And then finally, negative 3i times 3i would be negative 9i squared. From there, combining like terms, and I'm going to do a couple steps in one. This is 6 times negative 1. So this will be negative 6. Maybe I shouldn't. So I'll do negative 8. And then I'll go ahead and combine these. Negative 6i plus 8i is 2i. And then that'd be 6 times negative 1. And then from there, it'd have 16 minus 9 times negative 1. And then from there, that's negative 6 plus negative 8. What, negative 14? Plus 2i. All over. That'd be plus 9. Negative times negative is plus. 16 plus 9 is 25. And then breaking that into the real part and imaginary part, that'd be negative 14/25 plus 2/25. And there you go. And as a reminder, same thing. It's kind of nice. All right. Well, I know I did not cover every type of problem. I covered as many problems as I could. I do have people that are waiting on me in my office hour link. So again, I'm going to sign off. This is just extra practice. There's nothing new. If you have questions, refer to the notes. So you can refer to the notes for complex numbers. You can refer to the notes for transformations. So today, all you need to do is get this practice done, check your answers, and if you have any questions, feel free to sign on the office hours. That's where I'm about to go. So have a good day. Nice seeing you. And sorry about the internet problems. All right. Bye-bye.